Okay, so if you saw my last video, you'll see how it took me 14.5 minutes to evaluate the integral of secant of x, which is a record that I don't want to beat. So this one was a question, and the answer is like natural log of secant x plus tan x. I think there are lots of fast ways to get it, but I clearly didn't know any of them when I tried it. We're going to try a very similar question now, without using anything from here. And this one is the integral of 1 over sine x, so 1 just cosecant of x dx. All right, let's get started. So I'll hopefully not follow the same logic as I did last time. But one way, we want to basically put this into sines and cosines, because as it is right now, there's really nothing we can do with it. And if we have sines and cosines, either we can make cancellations or use some trigonometric tricks, or we can also use u substitution, because that will come up because sine and cosine are derivatives of one another with or without a minus sign. So with that being said, let's just do this. So sine of x times sine of x times 1 over sine of x dx looks very ugly because there are now three terms being multiplied, or three factors being multiplied. But all we did is just move the dx out here, so it looks a little nicer, and then multiply by 1 sine x over sine x. Now this is just sine of x over sine squared x, so it's really not some genius work here. But the nice part is that we can now rewrite this like so, right? And now, yeah, I mean, I guess we can just break it up now. So we can rewrite this as sine of x over 1 plus cosine x, 1 minus cosine x, which is just a difference of squares. And the nice part about this is that um, 1 plus, so there are a few nice things about this. One of them is that they're very close to each other. They're just a minus sign off, so we can rewrite this as, I think, 2 minus cosine x plus 1. And now this term and this term are the same thing, so we can make a substitution there. And then the other nice part is that the derivative of that is sine x dx, which is exactly what we want, right? So u equals cosine x plus 1, and then, well, actually, no, not quite. Du is equal to negative sine x dx. So that's the only thing to be careful of here. But it's actually not going to be that bad. Anyway, yeah, let's go in with this now. So if this is u, we just have negative du over u times 2 minus u, but then this just becomes du over 2 minus u, u minus 2 times u, right? I don't know why I wrote it this way. And this is now a nice, easy difference. So partial fraction decomposition. So how do you want to do this? Well, we can just do it like this. And we just want the numerator to equal 1, right? So, okay, we wanted to equal 1 over u times u minus 2. And so au plus bu equals 0. And then negative 2b is equal to 1, which means b equals negative 1 half. And from here, of course, we know that uh, u is not equal to 0, so we can divide by u and we get a equals negative b, which means a equals positive 1 half. So now what do we have? Now we've got 1 half times 1 over u minus 2 minus 1 half times 1 over u, integral of this du. And what do we do here? Well, now this is just 1 half natural log of the absolute value of u minus 2 minus 1 half natural log of the absolute value of u plus c. How do we want to simplify this? Well, we can take the 1 half out. Now we have natural log of u minus 2 over u all to the 1 half. And make sure you understand the way we did this, because we had the 1 half factored out, so it becomes natural log of u minus 2 over u, and then we put the 1 half back in as an exponent, which is a property of logarithms. Just brush up on those if it didn't make sense to you. Anyway, now we're here. We know that u is equal to what? Remember, you can't submit this, right? Obviously, u was not part of the original question, and you could have defined it in any way you wanted. So we have to go back to our definition here of cosine x plus 1. And so now what do we have? Now we've got natural log of cosine x minus 1 over cosine x plus 1 to the 1 half. Few different ways of now going about simplifying this. I think probably the nicest one is to multiply by cosine x minus 1. So this is now what we get. Sorry, cosine x minus 1 or uh, 1 minus cosine x, sorry. But yeah, I mean, whether it's 1 minus cosine x or cosine x minus 1, we're going to get the same numerator of this squared, all of this 1/2, and then it's 1 minus cosine x, right? Okay, so this is what we have, and then plus c. Now, just for the sake of being, oh, sorry, 1 minus cosine squared x. So now it's natural log of 1 minus cosine x over sine x, absolute value. Just to be like very, very clear, right? The reason we have this as 1 minus, so first of all, everything has to be in absolute values. So I could write 1 minus cosine x or it's negative. It doesn't really matter because the absolute values will take care of the sign for us. But I just wanted to be a little bit more, yeah, the reason I would 1 minus cosine x is because this is always greater than or equal to 0. This will never be negative because cosine x will never exceed 1. Actually, cosine x should not be 0 here either, because obviously that'll give us natural log of 0 over 0, which is ugly to work with. Anyway, yeah, now we've got this. So this would be correct, but we can also just write it as cosecant of x minus cotangent of x plus c. So this should also be correct. And I think this is probably what you'll see in textbooks or whatever if you try it out. Now, I do want to be careful, right, because I think I've messed this up in the past. So let's just check the integral of cosecant x, and hopefully we'll get something like this. 1/2 natural log of cosine x minus 1 over cosine x plus 1. That works. I think this is, maybe I made a small mistake somewhere, and that'll be equal. But actually, now this came across, I just saw this. You can also write this as, what is it? Yeah. Okay, so because of the square roots, right? So let's just go back up here, and I'll show you this. This is actually pretty nice. We can write this as the natural log of the square root of cosine x minus 1 over the square root of cosine x plus 1 plus c. And that's going to be exactly the same as the natural log of cosine x minus 1 over 2 over this plus c. And it looks like, oh, what are you doing? Is this some voodoo magic? No, it's actually the half angle formula. And what we get here is natural log of sine of x over 2 over cosine of x over 2 plus c. And so it's kind of nice because now suddenly you just get natural log of tangent of x over 2 plus c. So this is a little bit more compact, a little nicer. And obviously we know that these are equal, right? The constant and everything is also going to be the same. And so a nice little property maybe is that cosecant of x minus cotangent of x is equal to tan of x over 2. Now, needless to say, you don't need to do this entire integral to figure this out. You could have just gone from this expression and written it in two different ways. But I think it's still interesting to know, right? I mean, I didn't know this off the top of my head. So, I don't think it's going to come up on exams like show that these two are the same thing, but it's always still good to know. Provided I did it correctly, right? Now, maybe there's some gaping mistake or a gaping hole in the work that I did here, and so this might be wrong. So just double check that. Hopefully you're checking this with a pencil and paper or whatever on your own as well. But yeah, that's it. This answer should definitely be correct. This answer should, wow, the arrow came on its own. This answer should also hopefully be correct. And then yeah, I mean this answer, all of them are the same thing, so I don't want to waste your time anymore. That's it for this video. Hopefully you enjoyed. Thanks so much for watching. Bye bye.